Hello. So today we're looking at Leetcode problem number 3362, which is zero array transformation, third in the series. Okay. So in this problem we are given two things. The first one is the nums array, which is nothing but list of integers, and the second one is queries array, which is nothing but list of integers, which is that within every list you have actually two integers, which is the left value and the right value. So this um, defines a range. Okay, let me do one thing. Just add another thing so don't mess up with the question. Right. So now what the problem says is that given the nums list, which is bunch of integers, we need to identify um, number of queries that we need to use in order to make this nums list into a zero array. A zero array is an array which only has zero in its values. And so how is that possible? So once you select a query, the numbers that fall within the range of this query, both left and right included, can get decremented by 1. So if you have integers bigger than 1, you'll have to use multiple queries to decrement the value that many times to get it to 0. So this is a question. Now let's talk about how do we think through this. So one important thing to note is that when we talk about our queries, which is nothing but an list of some values, okay, li comma ri, these are actually indexes of nums array, because what we are saying is that this is a range. Okay, and if we want to process our nums, okay, step by step, let's look at the 0th index, and look at the first index, and then look at the second index, and see for the 0th index how many queries do I need, and then same question, how many. If we do it this way, we are actually executing this sequentially. Okay, but our queries are unordered. Okay, you can have 0 comma 2, you can have 1 comma 1, and then you can have another 0 comma 2. Okay, and if this 0th index happen to be 2, then I need to use these two values, and it will be very useful for me if these two values are actually sorted. So that's the first important point, that we need to sort queries by the starting index in ascending order. Okay, now the second important point to make is, let's say I have some values that looks like this. Okay, and let's say I have a range that is probably like this. Okay, then what the question says is, what is the minimum number of queries that I need to pick in order to make this a zero array? So if this is Q1, this is Q2, this is Q3. Obviously, if I pick Q3, I am able to cover a good number of elements. And imagine if this was just 1. Then just with Q3, I am done with 3 indexes. Okay. But if this is 2, then I can include this one and this one as well. But in order for me to get the least number of things, or maybe let me just transform the operation a bit, right? So let me say that I have maybe this is Q1, and let's say this is Q2, and then let's say this one is Q4. Okay, so imagine if I use Q1 first, what happens? My value gets transformed to 0, 1, 1, 3. This is after using Q1. I don't need to use Q2 because I already have 0 here. So that's okay. Let's leave that. Then imagine I go and use Q4. Okay, so what I've done is I have transformed this using Q4. And then I have another query, Q3, that I'm looking at, which comes after all of these, with which I can reduce this to 0. So then I use that. But notice what happens. The Q3 overlaps with this and is also overlapping, basically overlaps until this index, the second index. Okay, let's see. But the second index is already processed by Q4. So now when I'm using Q3, I am not using it to its fullest potential. What does Q3's fullest potential mean? That I can update the 0th index and I can update the second index. But what happens if I use it much later? I'm not using it to its fullest potential and I'm only using it for the 0th index. Now, what would have happened if I did not execute it in this order, right? So let me just quickly remove this part. What would have happened if I use Q3 first? Okay, so let's say I use Q3 first. I got 0, 1, 0, and 3. Okay, let's even assume that this number is not even there for the sake of simplifying our discussion. Okay, now I only have this element left out, so I need to use only one more query, and that can be Q1. Okay, so as you can see, I have used 2 queries here as compared to 3 queries before, and the objective is to minimize the number of queries used and thereby return maximum number of unused queries. Okay, now what does this mean? This means that at any starting point, so our starting point right now is this 0th index. Okay, this is where we are starting. At any starting point, I want to first pick the longest range query. Okay, so this is the longest range query, and I want to pick this first because this gives me maximum result, okay, with minimum effort, so to say. Okay, so apologies, there was a little bit of a technical snag. What I was saying here is that we need to use at any starting point, let's say our starting point is the 0th index. At any starting point we need to use, okay, I think I'm back now. Yes, at any starting point, let's say we're starting at the 0th index, what we want is the longest range query from there. Okay, this is the longest range query from the 0th index, from this place. Okay, so we want the longest range query to get the maximum result, okay, with minimum effort. Alright, so I hope the 2 important points that we wanted to make here is clear. The first one is that we will need to sort the queries, and the second one is that at any point or at any index of nums, we want to take the query which gives the maximum result, okay, which is going to be the longest possible query. So what we're going to do is we're going to use two heaps. Okay, this is heap 1 and this is heap 2. This one is going to be available queries. Okay, what does this mean? If you are at this position in nums, what you're saying is what are the queries that are basically starting from this point. Okay, and from these you want the longest range query, so this is going to be a max heap. Okay, and then you also have used queries. Okay, here what we're saying is that if you're at this point, how many queries that has been started in the past is overlapping with this position. Now this is important because if we chose the longest running query in our previous step, that query is probably still active and we still want to use it. Okay, and so that query which started earlier is going to be sitting in this. Okay, but as we progress, we have to remove the expired queries. Okay, what does that mean? Let's say this particular query ends with this position, right? I'm at the marked position of x. So now when I go for the next iteration, this cannot be counted as a query that is covering x plus 1. Okay, this cannot be a query. This query q dash that I'm looking at cannot be counted as a query that can satisfy x plus 1. So I have to remove this. And so what do I have to remove? This one can have multiple ranges. I have to remove the minimum value of this query. Okay, minimum which is lesser than or equal to. Apologies for the multiple on and offs. Today the screen sharing is not supporting me. So what I'm going to do is I'm going to complete the explanation and then we will look at the code on Leetcode directly. But the point that I was making before is that we will have multiple ranges of queries here. Okay. And what we want to do is actually exhaust all of the queries that are ending here or have ended before. But because I'm doing this cleaning up at every step, what was ended before would have already gotten cleaned up. So ranges that ended at the previous step have probably already already gotten cleaned up. And so now I'm looking at a range that is ending at the current index. Okay, and I want to eliminate all of this. So I want a min heap here. Okay, so this is a logic where think of this as a bank, okay, or your pool of resources. Okay, if while processing nums, okay, if you get to a value which is greater than the number of elements sitting in your used queries, that means you need to take one more query to satisfy this x. Let's say your min query had two queries, but let's say this value happened to be 3. That means you need to draw one more query to your used query from your available set. And which one are you going to take? You're going to take the longest available. And that's why you have a max heap here. And of all of the queries that you have used here, what are the queries that are ending at current index. What are the queries that are ending at current num index? Why current nums index? Because anything that was ending at previous nums index has already been removed, which means currently this used queries heap only has queries starting with only has queries ending with current nums index and beyond. Okay, so now we need to find the minimum, where the minimum is ending at current nums index, and if there are any such queries, then we want to remove them because they will not be valid in the next set. This is the overall logic. So we see if the screen share, no, the screen share is a little laggy. Okay, let's try. If it doesn't work, I will screen share the Leetcode solution. Okay, so let's come to the pseudocode. Def max removal. Okay, so the first thing we need is the available queries, okay, which is our max heap. And remember, this was our pool, okay, pool of queries starting pools of queries. Okay, there is a catch here. Since we are not cleaning up this max heap or the pool, we can have the longest range, but they could be starting much earlier as well. So, and they could also be ending much earlier, because since we are looking for the longest query, we are not doing any cleanup of anything, any shorter queries. So, for example, if a query was this long, okay, and when we were at 0th index, we picked this up, okay. Let's say there was another query that was this much, okay, and we move ahead to 1, we move ahead to 2, we move ahead to 3, we kept using this query only, but we never had the need to use this query. Let's say at the 3rd index, the count was 1, 1, 1, but here the count was 2. Then I needed another query, okay, and let's say this query was also quite big. Let's say it was this big, okay, so this happened to be the next max, okay, this query. Now, even though this query is the longest, it is starting and ending much before our needed index. So we have to have a validation check when we pull something from this maxi. But anyhow, let's for now just declare the variables. Okay, and then we have our used queries. Used queries, if you remember, is our min heap of currently active queries. Okay, now this we are managing. Okay, and so this is always valid ranges, and the reason why we are managing this one is because we will be doing our exact calculation of whether this value can be satisfied with my used queries or not. Okay, so this needs to be clean. Okay, this is an operation that is happening at every step, whereas picking the next longest range is something that we might not be doing at every step. Okay, we might never, there can be a chance that we may never even use it. That is why this is slightly impure, but this is always pure. So when we pull any value from this, we should validate. Okay, cool. Now we also need another flag or a counter. Let's call it applied query counter, which is equal to 0, which is going to be valid queries that we have picked out from our pool. Okay, that will be the valid queries that we pick up from here. Cool. Then we need a query index, because for every nums position we will be processing multiple queries. Okay, so let's get forward. So for nums index in range or len of nums, okay, our step 1 says that we have to pick all queries starting at current nums index and push to available queries max heap. Okay, and keep this pool ready. The reason why we are doing this is because when we want to use it, our queries should be readily available. That is why we're gonna have this step here. So let's do that. So while query dot index is less than len of queries. Oh, I forgot another really major step. Let's add that here. That our queries have to be sorted. Okay, let's move this a little bit lower and come back to here. So queries dot sort of key, it has two values. We will use the first value to sort the queries in ascending order, and this is in place sorting that we are doing. Alright, so once all of that is available, now we are checking if the queries are still there and the query idx of 0 is equal to nums id. That means we have a new range which is starting from this particular query, this particular index. We have a new query range that is starting from this particular nums index. We want to pick it up. Okay, so pick it up, we say end is equal to queries of query idx, take the second index, pick the end value. We're gonna use only the end value for the heaps because that's going to simplify our operation. So we say heap q dot heap push. We want a max heap, so let's multiply n with -1. So we'll say available queries minus n. So this is what we push, and then we say query index can now move forward for me to pick up another query if it is starting at this index. So this is the first step. This is just the processing of queries, getting that ready, and the maxi. Now comes the step 2. Step 2, we check if the value, or let's say the nums value at nums index is lesser than or equal to len of available queries. Then what that means is that either this value can be 0, it can be 1, whatever this value is. It means that if it is less than the length of available queries, then what that means is that with existing queries itself, we can satisfy this index. Okay, but if this is the case, then we don't have to do anything. So let's look at the other case when this is not happening, when the value is greater actually. Okay, so let's say value is equal to nums or nums id x. Okay, while available, because we'll have to pop from available queries, so while available queries and value is still greater than, sorry, available query is our pool, so I need to call this the used queries. Did I name them right? One second. Yeah, so available is the maxi pool, used is the active queries. Okay, so here what did I do? Queries push available. Yeah, this was okay. So we were making the available queries, the pool, that step was okay. Just here, while available queries are there, and yes, now here I need to use the used queries. Okay, if the value is greater than the len of used queries, okay, then I need to pick something. Okay, I need to pick something from my available queries and add it. So let's do that. So n is equal to minus of heap q heap pop from available queries. Okay, so you pick the longest most thing. Now remember, we have to take care of anything that we are picking out from available queries, because there is a chance that the query probably already got expired. So we need the n to be greater than or equal to nums idx. If it is greater, then let's add it to the used and use it. So heap q dot heap push of used queries, you're adding n to that. Now, when you go back and check this condition, is the value still greater than the len, or did they get satisfied? Okay, so you do that, and then what you also do is you take your applied query counter, and then you increment it to 1. Let's do it like this. Okay, and when this while loop ends, okay, when this while loop ends, there are two states that are possible. Either my value now has become equal to the length of the use query, which means I was able to satisfy and pick x queries to match this value, or my value is still greater than used queries. Okay, so let's handle that edge case. So this is the end, one of the end case. If value is still greater than len of used queries, then I have to return -1, because I don't have enough queries to satisfy that value. Okay, now if this hasn't happened and I was able to pull up enough queries to match my value, then great, let's proceed to the next ID of the nums list. But before we go there, we have to take care of step 3, which is update our used queries. Okay, and remove all queries whose range ends at current nums idx, because in the next iteration when we go to nums idx plus 1, this range is invalid. Okay, so when we do this comparison of value greater than the len of this will give us incorrect results. So we have to handle this one, and this is important. Okay, so while we have used queries and used queries of 0th index is equal to nums id x. That means it's time to pop it. So we say heap q dot heap pop of used queries. Okay, so that's about it. After this, it goes back to the same iteration of nums, and it starts with the same step one. Pick all queries starting at nums idx, add it to the available queries, keep it ready, and then this is max heap. So if this was the longest range possible from here, it would pick that up, and so on. Okay, so finally we return len of queries minus applied query counter. So this is what we have used, and so this is what the problem asks, which is the maximum number of unused queries. Alright, thank you. See you next time.